Welcome to this tutorial on Kubernetes Headless Services. In this video, we'll explore how headless services enable direct pod access, which is essential for StatefulSets and pod-to-pod communication. Headless services are a special type of Kubernetes service that give you fine-grained control over how your applications connect to individual pods. A headless service is a Kubernetes service where you set the cluster IP field to none. Unlike regular services that return a single cluster IP address, a headless service returns the individual IP addresses of all the pods that match its selector. This means there's no load balancing performed by Kubernetes, and DNS queries will return all pod IPs directly, allowing clients to choose which pod to connect to. Let's compare normal services with headless services. When you query a normal service through DNS, you get back a single cluster IP address, like 10.96.0.15. The service then load balances traffic across all backend pods. With a headless service, DNS returns multiple IP addresses, one for each pod, such as 10.244.1.5, 10.244.2.8, and 10.244.3.12. The client application connects directly to the pod of its choice, without any intermediary load balancing. Creating a headless service is straightforward. You define it just like a normal Kubernetes service, but with one critical difference. You set cluster IP to none. In this YAML example, we specify the API version as v1, the kind of service, give it a name in the metadata section, and in the spec section, we set cluster IP to none. This single line is what makes it headless. You also define a selector to match your pods and specify the ports your service will expose. Headless services are commonly used with StatefulSets to provide stable network identities for stateful applications. They're perfect for database clusters like MySQL and PostgreSQL, where each database instance needs to be individually addressable. They're also ideal for distributed systems such as Kafka and Cassandra, where nodes need to discover and communicate with specific peers. Search engines like Elasticsearch also benefit from headless services for node-to-node coordination. When you combine a StatefulSet with a headless service, each pod gets a predictable and stable DNS hostname. The pattern follows this format: podname.servicename.namespace.svc.cluster.local. For example, if you have a MySQL StatefulSet, your pods would be accessible at mysql-0.mysql.default.svc.cluster.local and mysql-1.mysql.default.svc.cluster.local. This predictability is crucial for stateful applications that need to maintain persistent connections or data replication relationships. Here's how you configure a StatefulSet to work with a headless service. In the StatefulSet specification, the service name field references the name of your headless service. In this example, we're creating a MySQL StatefulSet with 3 replicas. The service name field is set to MySQL, which must match the name of your headless service. You also define selectors and labels to ensure the StatefulSet pods are associated with the headless service correctly. Let's recap the key benefits of headless services. First, they provide direct access to specific pods without any load balancing in between. Second, they offer stable identity through predictable DNS names that persist across pod restarts. Third, they enable peer discovery, allowing pods to find and communicate with each other directly. And finally, they're essential for stateful applications like databases and clustered systems that require consistent network identities. Understanding headless services is fundamental to mastering Kubernetes networking for stateful workloads.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.